Hello and welcome back to the OpShin Pioneer Program, and welcome to Lecture 3, Week 3, Lecture 1. In this lecture we will delve a bit more into the script context type, which is all the metadata about the transaction that we receive when we construct, when we try to validate, we as the contract try to validate the transaction on-chain. So, yeah, recall that when we define a function, we define a validator, we define a smart contract as a function that takes three arguments: the datum, or the state of the UTXO that we're consuming, the redeemer, which is an action that's passed in by the user, and a context, which is what we are talking now about, the basically information about the entire transaction that we want to validate. Previously, we've seen only redeemers in action, but the context was we didn't really look at. So yeah, what is in there? In Bitcoin, maybe you have seen this. There's some very minimal context provided, which is, I think, the time and some signatures. In Ethereum, we see the entire blockchain at the time of our script executing. And in Cardano, we are somewhere in the middle. We see a lot of information about our transaction, but we don't see the entire blockchain. We see, for example, when is the transaction valid? What will be all the inputs, what will be the outputs, what is the fee, what datums are attached, what are the reference inputs, and so on. So who signed the transaction? This is like a local view on our current transaction and the part of the global state that we are consuming and depending on, but we don't care about the rest and we don't need the rest. And this is already, if you heard about smart contracts are deterministic on Cardano, this is exactly where this comes from, because the transaction can be evaluated only based on this local state of the inputs and the outputs and the transaction validity. And they are deterministic in a sense that if any of these values are not, when we're trying to submit a transaction, if any of the values are not how they are defined in this context, then the transaction will fail. And this we can already evaluate when trying to submit, and so most likely we'll actually never submit a failing transaction, because it can be very easily validated that it will fail already. Okay. So now let's have a look at the script context data type. I've opened in the background book.opshin.dev, which is a convenient website for all kinds of introduction to OpShin smart contracts and EUTXOs. For example, here's a full introduction to EUTXOs based on a guide written by Matthias Bencourt. There's also, if you are new to Python, an introduction into types and classes and variables, loop statements, functions, and so on of Python, and which of these we use in an OpShin. And then there's a tour on smart contracts, which defines how exactly validators are defined, and the script context. So what is the script context? It's defined as a Plutus datum object with has constructor ID 0, which we cannot see here. And then it has two attributes. One is auxiliary information about the entire transaction. That's txinfo, and one is the script purpose. So you have learned or maybe heard already that we can write validators for a lot of different smart contracts for a lot of different purposes, like spending funds, minting tokens, withdrawing funds, and so on. And depending on for which purpose your script is spent, this the script purpose field will be set. So, for example, if you have if you build a transaction and your smart contract validates that you are spending funds from a specific UTXO, then the script context will have in the field purpose spending, an object of type spending, which defines which UTXO you're exactly trying to spend. If you're trying to mint a token where the policy ID is exactly the smart contract or the hash of the smart contract, then to validate that you are able to mint, the purpose will be called with a minting, like you will obtain a script context with minting as purpose. For withdrawal and certification, it's similar. Like depending on what the smart contract should validate in the transaction, it will receive a different purpose here. And let's have a look at txinfo, which is a bit more complex. So this is our view of the transaction. What you will so let's just go through all the fields that will comment a bit on what they do. So inputs, you build a transaction, it consumes a number of inputs and it produces a number of outputs, and inputs is exactly the list of inputs that your transaction is consuming. Among these inputs is your own input if you're spending script. If you're spending a smart contract, then one of these inputs will be your own UTXO. Then there's reference inputs. These are can be used depending on what you need them for, but they are more generally some state, some UTXO that exists on the chain currently, but is not. You don't have to spend it to actually read from it. So imagine that we don't have this field. Then if you want to say there's a smart contract with a pool, and the state of the pool is the datum attached to that UTXO. So imagine you want to have a second smart contract that reads the state of the pool. Then if you don't have reference inputs, you need to actually spend the pool. You need to spend that input only to be able to read this datum, because as we will see, there's no other way to reference UTXOs on the chain that we depend on. And that's why how the reference UTXOs were invented. Reference inputs, it's a list of inputs that we don't really spend, but you just want to read from them. And yeah, we will see later how these are useful. If this is a bit too abstract for you now. Then there's the outputs, because also as a script you want to control where will our outputs go. Imagine you are a pool, a liquidity pool of tokens, and you want to make sure that when you are spent in the input, then also you are sent back the tokens. Most of the tokens will be sent back to the contract, and only what was swapped away can change. So yeah, you have inputs and the outputs, and both of these you can see. Then you can see the fee. This might be useful, might be not. Usually I've never seen a contract actually depending on this, but you never know. And then there's a value minted in the transaction. So as you might know, there are native assets on Cardano, and if you want to mint or burn these native assets, there will be some form of script controlling this. There can be native scripts, which we don't cover in this course, but there can be OpShin or other Plutus contracts controlling it. And either way, they will show up here in this, for a smart contract, they will show up here in the mint field. So for example, as a minting contract, sometimes you want to control that only one token with your policy ID is minted and not multiple ones. So you can go and check in the minting field that the policy ID for your own policy ID, there's only one token. Then there's certificates. These are actions relating to delegating to a stake pool or deregistering, registering a stake address. This is more specific to the liquid staking system in Cardano. These can also be controlled by smart contracts. There's withdrawals. These withdrawals, that's when you withdraw funds that have been allocated to your account, to your staking account, to any staking account really. And we can also inspect this and control them. It might be useful for things where the script, you have a script that controls these withdrawals, and you can check that it's present and how much was withdrawn in this dictionary. Then there's a validity range. We will dive a bit more into this later, but generally this just says, okay, the transaction that we are constructing here, it will be valid, let's say, from today 0 to today noon to tomorrow noon, etc. And or something like this, right? And the reason we have to provide this is that we are constructing the transaction at one point, then later we are submitting the transaction to the chain. But the contract has to be evaluated already when you're building the transaction. But there it's not known yet when the transaction will be actually on chain. And to preserve the determinism, we just say, okay, the contract does not have to know when exactly it's submitted. It just needs to know a time range. And if the contract is valid in all of this time range, then perfect, then it will just go. And maybe it will not be fine, and then you have to restrict the time range a bit more. That depends a lot on your use case. This time range can also be open-ended. Per default, it's from negative infinity to positive infinity, so the transaction can be submitted anytime. But as soon as your contract has any time dependencies, you will want to set the time range to some specified range. Then there's signatories. This is a list of users that so pubkey hashes, right? So this is a list of users that do traditionally, using a secret key, sign this transaction, or they have to actually sign this transaction, otherwise it will not be valid. Again, this stems from this fact that you have to preserve determinism. A transaction on Cardano does not have all the signatures already when you're building it. Only after you build it, you add the signatures. So we have to somehow tell the contract, okay, yeah, already when building, here are some signatures that you can sure will be present when we finally submit the transaction. No one else can submit this transaction. And yeah, so that's the signatories list. And this is also something, per default it's empty, even if you spend funds from your own from your own address. The contract does not know that you are also signing this transaction because you're not in the signatories list. Of course, you can write your smart contract in a way that it goes through all the inputs and says, okay, all the payment keys that spend all the any of these inputs, they are also valid. I also count them as signatories or something like this. But the easiest way is to really look at the signatories. And then you just specify when building the transaction, okay, these people have to have signed the transaction, otherwise it will not become valid on chain. And the node will check this when processing the transaction. Then there are two maps that are relatively useful to have, which is redeemers and data. These map from who is being invoked in this transaction to what's the data that they receive. So what you can actually check here is, okay, there's a minting script with a specific policy ID. I want to see the redeemer for it. You can inspect this here. Or there's a spending script from a specific address. I can look at the redeemer. I can check that, okay, all the funds from this that are spent from this address have to have the swap redeemer and not the cancel redeemer. This you can actually validate here. And then there's data field where, for example, you have a transaction and a UTXO input, and there are different ways that the datum can be attached to a UTXO output. And one of these ways is the inline datum, which is what we're usually using. Then you can already find the datum directly at the transaction output. But you can also just attach a hash. And then this data map can be used to resolve from a hash to the original datum. That's very useful to have. And finally, there is the ID of the transaction, which you can usually not work with because the ID is only determined as you build the transaction, so you cannot really provide it before constructing the transaction, but you could anyways look at it if you really want to. Right. So one thing you might have noticed is that inputs have a field txinfo versus outputs have txout. And there's a slight difference here. The difference is basically this. Txout is present in both types, and it basically describes an output. It's an address, where are funds locked. It's a value, which tokens, which assets are locked at this address, and the datum, which is what I just described. It could be an inline datum, it could be nothing, it could be a hash of a datum, and then a reference script, which usually don't use in a smart contract itself, but you can attach a script to a UTXO, and then when you spend it, you get a much cheaper transaction because you don't have to involve the whole smart contract. Recall that when executing a contract, all the node knows beforehand is the hash, so you have to provide somehow the entire contract when trying to execute it. And traditionally, you would have to include the entire script into the transaction, and it would be duplicated thousands of times. Every transaction contains the entire script, which leads to bloat on the blockchain and expensive transactions and so on. So one way, what you can do is you can attach just a script to an output on the chain, and then you can include this as a reference input, and the node will automatically resolve the correct script. So this could potentially also be in a txout. It will likely also be in a reference script txout when you have some in your script context. But the most important parts are address, value, and datum. These you always access, or you most of the time access. And then this is what you see about tx outputs. And then there's a second field for inputs. So if you look at info, they have two fields. There's out reference and there's resolved. And resolved is exactly your tx output. So this basically tells you, there's an address, value, and datum, and maybe a reference script at this input I'm consuming. But then there's also an out reference. And this out reference contains of the transaction ID and the input index. So The reason we don't have this for the TX out is we don't actually know it before we construct this transaction, which will be the transaction ID and the index of the output. And you can also easily reconstruct it by using the index of the TX out and the transaction ID. But for the inputs, we already know them and we try to consume them, and you can look at them. And there are some scripts, for example, one-shot NFT scripts, that require we spend a specific UTXO. And with this already, they ensure that a specific token can only be ever minted once, because, I mean, it's not guaranteed, but it's extremely unlikely that there will ever be two UTXOs with the same hash and index. So this is one application we have for this. Right. So whenever you think about, I want to implement some functionality in my smart contract, you will most likely use the script context in some way, because you want to check that, there's a specific relationship between inputs and outputs, there's a specific fee, mint combination, some withdrawals, something like this. And all of this you can find in the script context. Okay, the next lectures of this week, we will dive a bit deeper into specific parts of the script context and how to use them. Looking forward to meet you there.